as you're working through studying for this test, if you don't have that's where it starts, is you have to memorize the 3 inverse trig function derivatives so that you can recognize the antiderivatives. I would say arc secant, arc sine, and arc tangent are important to know because the other ones that start with the C, like arc cosine, arc cosecant, and arc cotangent, are just negative versions of those 3. So start with that, start to look at that and make sure you have those memorized. And you should recognize that this one is very, if I were to look it up, the derivative of arc secant of x is equal to 1 over, and you see these absolute value symbols, which aren't real significant at all, except for the domain of it. We don't ever really have to worry about it. As you guys can see here, it was dropped from this integrand because the interval is from 2 to 4, so it doesn't matter anyway. So in this antiderivative, I messed up and put 4 there. It should be 1 is the original. This is what you guys would see if you open up your cheat sheet. This is the derivative of arc secant. So we see there is a similarity between this, and I would say, how do you know which one is which? The arc sine one has 1 minus x squared at the where x squared is in this spot. Tangent is 1 over 1 plus x squared, and the complicated one is arc secant. So kind of think of the one that you guys learned last when you were going through your trig stuff as the one that's most complicated, with the x and the x squared right beside each other. One outside, one inside the square root function. Okay, so I recognize this. That's the first step. Recognize what antiderivative it is. And then go to the spot where there's a constant. So for the arctangent one, it was like x squared plus 4. And then I manipulated that plus 4. In this case, this is supposed to be minus 1, and it's not. And so I'm going to do an algebraic manipulation here to figure out what is the input that was supposed to originally be here. And after you guys do a few of these problems, I think the first step, you don't really have to do as thorough of a work afterwards as I'm going to show you guys. I'm just proving to you that it is mathematically equivalent, but you don't have to show all those steps. So this being the first time you guys are doing it, I just wanted to show you that. So when I divide through by 4 to force this to be 1, remember that everything we do has to be a balance. So we're going to divide through this whole, each one of the terms within this expression by 4. Notice that the 4 isn't outside the square root, but inside the square root. Okay, so if it's inside the square root, then you guys really divided not by 4, but by the square root of 4. And I'll kind of insert this, the square root. You guys want to picture the square root being there. So actually, let me get rid of that for now. Okay, so what is it that you guys really multiplied this denominator by? What did you guys multiply this by? Like, what should I multiply the top by as well? What is that expression? Okay, so yes, we divided by 2, which is the same thing as multiplying by a half, right? We really overall multiplied the denominator by a half. I'm going to take a moment and pause there because this is the part that is confusing for some students. Some kids in 3rd period had a question on that. Does that make sense to you guys? Because you divided by the square root of 4, that means that you multiplied this bottom expression by 1/2. And so if you do the same on top, then we force it to be that you have the expression, the integrand is 1 over x square root of x over 2 squared minus 1. X over 2 being your input. Okay, so this is going to be equivalent to arc secant of x over 2. Okay, so our input is x over 2. Any questions on that? Okay, so that's going to give you guys what your input is. And some people like to view it instead as U-Substitution. So I'm also going to go over it that way. But I encourage you guys after that just to double check your work. Always try to take the derivative and see if you get back to the original expression to see if that's mathematically equivalent. So if I were to, let's say I was checking my work, and I'll just do it this one time. Let's say I'm checking my work just to verify that that actually is mathematically equivalent. Wherever you guys have the input on the left, you're going to input it into the x's on the derivative. So if I were to take the derivative of arc secant of x over 2, I would get 1 over x over 2 square root of x over 2 squared minus 1. Okay. Also, one thing that you guys have to keep in mind is arc secant of x over 2 is a chain rule problem, right? So you would have to multiply also by the derivative of x over 2, which is 1/2. Okay, so now when you take a look at this, here's my question to you guys. We're trying to verify that this is really the same thing as the integrand without any manipulation here. So what is it that you guys would have to multiply 1/2 by to get 2 on top? What is it that they multiplied by to change this 1/2 to 2? What is it that you guys multiply by? Okay, good. You multiplied the top and the bottom by 4. Okay, so top and the bottom by 4. And if you agree, this bottom 4 is the same thing as 2 times 2. So really you guys multiplied this one by 2, and I'll delete this 4 right here. So so you multiplied this x over 2 by 2, so that gets rid of that one. And then let's think about what happens here. If you guys square everything out, you guys really have x squared over 4 minus 1. If you factored out a 1/4, from that expression, you get x squared minus 4. Okay, and then this is all inside the square root. What's the square root of 1/4? The square root of 1/4 is 1/2. So you have the 1/2 on the outside, and that again is multiplied by the secondary 2 that makes up the 4. So I highlighted it, but this is the 2, and the 2 on the bottom makes the 4. That's going to cancel out with this 1/4 or the square root of 1/2 here, and this will cancel out. So we get back to the expression that we started with, which is over here. Okay, you don't have to go through all those steps, but that I wanted to show you guys algebraically how that worked, how that's mathematically equivalent. Now, some people prefer U-substitution in this case to just recognize what, do a U-substitution to simplify some of this algebra that you're doing all in your head. So again, this is not necessary. Really, ultimately, all you guys needed was to figure out arc secant of x over 2 was the antiderivative, but I wanted to show you those steps because it's hard to visualize with so many things going on. So if you're okay with that, I'm going to delete this in a minute. Actually, I'll just leave it there for now. U-substitution would have been a different way to attack this problem. I still would have started off with recognizing, again, that it's arc secant. Second, to figure out the input, I would force the 4 to be a 1 by dividing by 4. And then assuming that now, when I rewrite that expression, that the input is x over 2, I'm going to let u be equal to x over 2. Okay, if you guys do it this way, you can see that when you solve for x to do the u-substitution, you get 2u is equal to x. Okay, so if I rewrite the antiderivative, I get 2 over x is 2u, square root of 2u quantity squared minus 4. So I did a substitution of my x's to be 2u. And then on top of that, I also happen to know du is equal to 1/2 dx. Okay, so in replacing my dx, dx is equal to 2 du. So now if I replace my dx with 2 du, I notice that this 2 and this 2 cancels out. And once again, we have the expression at the bottom. Inside the radical, if I square everything out, I get 4u squared minus 4, or factor out the 4, u squared minus 1. The square root of 4 happens to be 2, and that's going to cancel the 2 that is part of the du. So I'll cross out that 4. So I end up with 1 over u squared of u squared minus 1, which is the exact expression that you would have over here, where x happens to be your input. In this case, we have u. And so if I were to write this, I would say arc secant of u, or u was x over 2 to begin with. So another way of just verifying that x over 2 is the input. And then I'll talk to you guys next about what to do from there. I had to figure out what the input was for what the inside function was for arc secant. So the question was, how did I figure out x over 2? That's why I said whether I do it this way or this way, I would still start the problem off here to figure out what the input is. And dividing by 4 is going to get me this expression that I could then rewrite as x over 2 quantity squared. So it's just to figure out what the input would be, how that would change it. And the reason why this number on the outside doesn't have the same exact x over 2 is because of the adjustments on the constants that we verified down here. With and also with the chain rule on it, it'll affect that constant on the outside. So go to the part where it has the plus or minus part. So on like your arctangent, you have like 1 over x squared plus something. Adjust that constant at the very end, and that's how you guys are going to figure out the input. Okay, so let's say again, all this work is either done in your head or after a while you guys are like, okay, I'm pretty sure it's this. So I'm going to delete this now. And I will post this video for you guys as well, so that you guys can go back to it if you need to. So in this case, for this problem, we did figure out its arc secant, sorry, my lights went out, of x over 2. And I'm going to change this. Remember, this was improper to begin with. There was a question on the homework assignment. Someone asked, how come 0 is not part of the vertical asymptote? What do you guys think? How come 0 is not part of the vertical asymptote? Or not part of the part that's improper? Okay, yes, we don't have to consider 0 because 0 is not within the limits of integration here. So only part of this that makes this improper is the 2 part, because 2 squared minus 4 is 0. So we're going to replace 2. Question yesterday at tutorial was, how do I know if it's coming from the left or right? So wherever your vertical asymptote is, in this case at 2, if your area, and I have no idea what this graph looks like, but let's say it's approaching it from on this side, our area is to the right of that. So if this interval is to the right, it's coming from the right, so positive. So if it's on the right of the vertical asymptote, it's approaching from the it's approaching from the right, so there's a positive sign. If it's to the left of it, it's a minus sign, so this is plus. And I'm going to change this to B because I made that replacement. Oh, I'm sorry, I haven't substituted yet. So our limits of integration are from B to 4. Okay, plug everything in, and I just want to make sure you guys remember how to do arc secant of 2 without a calculator minus arc secant of B over 2. Arc secant of B over 2. Okay, so we're going to let the limit approach 2 from the right, arc secant of 2. You guys can think of this as a secant of some angle. Remember, inverse is always like finding the angle. We're on this in a solid geo right now. Secant of some angle is equal to 2. Secant is the same thing as 1 over cosine. 1 over cosine, if I solve for this, this is asking me for the same thing as cosine of what angle is equal to 1/2. Okay, so if you're looking at a secant expression that you're trying to find the angle of, you can just simply take the reciprocal of 2 to get 1/2 and ask yourself cosine of what angle in the first quadrant is equal to 1/2, and that is pi over 3. Okay, so if you guys plugged in 2, apply the same idea. This time cosine of what angle is equal to 2 over 2, which is 1. We would get, cosine of what angle gets you guys 1, and that would be at the x-axis 0, right? So the angle 0. So pi over 3 is your solution to this question 11, which was a lot of stuff going on behind the scenes for figuring this out, but just getting comfortable with the algebra behind it. Are there any other questions on page 9 or page 8 that you guys would like me to go over as a whole class? I did a few, I can't remember which it was for period 3. Is there any you guys would like me to go over before I start to talk about what I'd like you guys to work on? Anything you guys have questions on, or you want to verify if it's the right way of thinking? Yes, and we're going to go over the starter review question as well. As you guys are looking over and seeing if you guys have questions, one note, I did this at tutorial yesterday, so if you guys want to take a look at that, that's fine as well. Number 6, But as we're going over these problems, I'm going to talk about the starter review because there's a few on there that's really important for your test. And then I put those questions again on your the discussion that is posted on Canvas. So please take a look at those. Those are going to help you in the multiple choice section and in the free response section. Then after we get through this, I'm going to have us do a practice free response, AP free response on this. And then we'll hopefully have some time for you guys to get started on the homework, or sorry, the discussion together. And then I'll talk about the optional assignment that you guys have as well. Okay, so no questions so far on this. So I'm gonna jump to the starter review question. How did I do that yesterday? I might just have written it out. All right, you guys, so if you've submitted the starter review, if I can have you guys resubmit it if you guys did not do 3 and 4, and resubmit it with 3 and 4 completed. I just didn't grade those of you who submitted it without it. Nice job to those of you guys who did do it. In the years past, I kind of just gave, there was a period of time where I just gave this on the test, and it always ends up being the most missed question on the test. Because it's very conceptual. So nice job to those of you guys who got it. Some years I just give it, and then, or before I would just give it to see who would get it, and it was not good. So what you guys are gonna do, yeah, and some people are gonna stare at this problem and not know where to start with this because it's got so much stuff going on. So I'm gonna break it down to you guys as essentially it's a limit problem. Okay, so if you think about the fact that it's a limit problem, think back to the first unit. What's your first step when you guys are doing a limit problem? What should you guys try? Can you guys type it out? What should you try? If you see it's a limit problem, what should you try? You should try direct substitution, exactly. So direct substitution would mean that you're plugging 0 in for your x's. The x's occur here. So if you plug a 0 in, you're finding an integral that goes from 1 to 1. That's the area underneath the curve where a and b is 1 to 1, which we know is 0. So then that's going to result in 0 on top, and then plugging 0 in on the bottom, we get an indeterminate form. So again, overall picture that I'm seeing is this is a L'Hopital's rule problem. It's indeterminate. And so the next step would be, what would I do if it's L'Hopital's rule? I would take derivatives, right? So now you are applying a derivative separately of the top and the bottom. So if I take the derivative of an integral, that's FTC. So I'm going to take the 1 plus x, the upper limit of integration, so long as this is a constant and this is an expression that I can plug into my t's, plug it into here and here, I get cosine of 1 plus t over 1 plus x over 1 plus x. And then the derivative of the bottom, don't forget to do that, is 1. And overall, it's a limit question. I've just applied the first step of L'Hopital's rule. Okay, so I would also want to caution you guys, if the expression on top is not just x, don't forget to take the derivative of that. In this case, the derivative of 1 plus x is just 1. So I would, I'm going to write the times 1 here just so you guys know I did consider that. So for example, if you guys had 2x up there, you want to make sure that you multiply this by 2 to account for the chain rule on this. So in this problem, it didn't affect it, but if you did have something that was other than x and it resulted in a constant, that's going to affect your answer. So keep that in mind. And then after that, direct substitution again, plug 0 in for all your x's. And our resulting answer is cosine of 1 over 1, or just cosine of 1. So kind of a neat conceptual question that we see very frequently on the AP test, and kind of a clever way of asking that type of question of L'Hopital's rule. Yeah, so L'Hopital's rule, we have FTC in it, so it's a complicated question. And again, I think there's an additional example 4 on there. So you guys attempt that. If you want to verify with me later, let me know. The other part that, and if you look at the agenda, I went ahead and described to you guys what was required and optional. So the maze, some of you guys started, some of you finished. I would say the pathway that gets you from the start to the end of the maze, I think has pretty straightforward questions. If you want additional questions just for practice, you guys can do the other questions that I did not cross off. The crossed off questions require you guys to know partial fraction decomposition or trig substitution, which is not covered on the Calc BC curriculum, and partial fraction decomposition with non-distinct linear factors, repeated linear factors. So I know that makes no sense to you guys, but what we covered in class is what you're required to know. And then that is an additional topic that is not covered on it. So I just crossed it off and said skip. You're more than welcome to do the remainder of the questions on the maze if you guys want for additional practice, if you have time. I would say ranking everything, get through the maze, and then after that, do the discussion. It shouldn't take you guys very long to do. You could see other people's responses. They've been good so far that I've checked. And then we're gonna do the free response in class and you'll submit it. And then I think, what else was there? Oh, there's a quizzes. Now that quizzes, when I look through the quizzes, that's pretty reflective of what your multiple choice will look like, as opposed to the review, which I think is a little bit more challenging. The quizzes is gonna be completely optional. So if you guys get a chance to work on it, great. It's just additional practice for improper integrals and L'Hopital's rule. So let me get to now the free response. If you don't want to print out and you guys just want to complete this on a separate sheet of paper, I'm going to pull it up. I gave the other class about 10 minutes, but they ended up needing 15 minutes, and then we'll just go over it. You guys, you just try your best on it, do your best on it, and see where it leads you. If you don't get a part, you guys can skip over it, and then we'll come back and I'll explain all of this to you guys. So this is the 2004 Form B. I did post it. If you want to just look at the screen and do it as it's on the screen on a separate sheet of paper, that's fine as well. If you guys want to step away and print it, that's also okay. I'm going to give you guys a total of 15 minutes to complete this because the last period actually ended up needing the 15 minutes. I was only going to do 10. So I will have you guys start and then check in on you guys. So go ahead and start on the problem. All right, you guys, let's go over the free response. So go ahead and give yourself a grade as we go through it. It was, I didn't notice that anyone asked me, like in period 3, quite a few people asked me about C during the free response. And I know that one and D is difficult. A and B, I would hope that you guys were able to get those without too many problems that occurred. So in let me actually find the scoring guide here. Okay, so for part A, you were asked to find the average value. We should remember the formula for average value of a function being 1 over b minus a, the integral in this case of g of x. Hopefully your integration was correct. A few people mentioned that they integrated incorrectly. So here is part A. Integrating it would have resulted in 2/3 once you guys evaluated the integral. 2 points awarded, one for the integral itself, like the setup of the integral. I would think the first part of this is 1 point. And then the anti-differentiation would be this part. And then the evaluation would be the 2/3. Whether or not they would award the 1 point if you guys, or half credit for whether you got the 2/3 or the antiderivative correct, I'm not too sure, but for now, I guess you guys can always grade it like conservative versus lenient. And then that's up to the AP readers as they're grading it, but 2 points for that. Okay, B also was something I hope you guys remember and also know it for your test coming up. Obviously, we should have this kind of in our minds of the chapter right before this was solids of revolution. So in the chat, can you guys tell me when you revolve a region about the x-axis or the y-axis, what is the shape that emerges? Like what is, if you were to slice that solid, what type of shape should you guys see at the cross sections of a solid of revolution? You were to slice it. Yeah, so some people said semicircle. So I want you guys to think of the things that we associated with solids of revolution. We called it discs and we called it washers, right? So it's, yeah, and some people, for whatever reason, thought it was semicircles or squares. So that was the kind of the hint that you needed for C, because for part B, you're gonna always envision solids of revolution, you're revolving something about, and so like, remember on that one practice problem that we did where it was a paraboloid, if you guys end up with a disk, and when we say radius, we're talking about a solid of revolution is revolving a point about an axis that is going to result in disks and washers, which are circles. And so essentially, when you guys are doing a solids of revolution, you're adding up a bunch of circles. And so in this case, when we say pi r squared, your circle is that area of one of the cross sections. So you guys can see here, I drew it on top. So I don't know exactly what the shape looks like, but that's okay. You just want to envision that circles are your cross sections. So for part B, go ahead and double check your work. R being the top of the function minus the x-axis, so 1 over square root of x. So if you squared that, you guys would have gotten the 1 over x that you see within the integrand right there. Okay, and so integrating that from A to B that was provided for you guys would have gotten you pi ln of 4 for the solid of revolution. So 2 points, one for the integral, one for the anti-differentiation and evaluation. So hopefully so far so good. That would give us 4 of the 9 points. Okay, part C. So part C, not a huge deal if you guys actually didn't get this. And this is where the AP test becomes one of those, they try to have you guys, think critically beyond just what's in the textbook and what we go over in class. So this is one of them. So I got about 5 people in period 3, they in the chat asked like, how come they don't tell us what the cross sections are? And so if you guys read it, it talks about the solid S, which is referencing part B. And so we would have to make that leap to conclude that it was a circle that this was referring to. So if we're summing up, if we think about cross sections as the integral of the area, in this case, on top of that, they wanted the average value of the area. So the area of the function is given by that. The average value of the areas of the cross section. So I'm going to integrate from 1 to 4. And then average value means that I'm going to times that by 1 over 4 minus 1. So down below here, you guys can see they integrated the pi over x that you guys actually had from the previous part as well. And luckily for you guys, that was only 1 point. Whether you got the answer or not was, I guess, even if you guys, that this wasn't even split into two points. So just 1 point for that. Okay, so I'm going to show you guys that even if you guys missed that one, that would have been +4 here. And then this last part, part D, even though there's parts of it you guys can see that's 5 points that we have already, there's 4 points left, and there's a lot going on with D, where D is asking you guys to find the average value of a function f on the unbounded interval. So this is what makes that integral improper. Is defined by the limit as b approaches infinity of a to infinity. So you guys can see that they replace it. If you think about this as infinity, that would have been improper. One side is unbounded, so they replace the b with infinity. And they're saying show that the improper integral from 4 to infinity of g of x is divergent. So this is the part that I would hope you guys all would have gotten. Even if you had no idea what that limit expression was, showing that that integral is divergent is part of this chapter. It's not very difficult to do. And then they wanted, the harder part was to find the average value and show that it was finite. Okay, so the average value going back to this expression here. So what I'll note is that you guys are given the limits of integration here. The average value of g would have meant that you replace g of x in this integral expression. You replace 4 here and for a, 4 to infinity, and then 4 at the bottom where a is. Okay, so as we go through this, go ahead and check the part of it that I thought you should have all gotten, which is the part of showing that the integral from 4 to infinity is divergent. Great question from someone in 3rd period. They said that as they were doing this part of it, they found the antiderivative, but then they stopped. They basically just wrote this expression that I'm circling, and they didn't write the -4, and they asked, would they have been marked off for this? So you guys can see over here that they awarded a point for 2 radical b -4, and they stopped because they knew that this was going to be infinity already. So they just said, okay, this is divergent. I don't have to write any more. So I'm going to encourage you guys to write out your answer. Yes, and then if you didn't write g of x, as long as it's clearly stated that g of x is equal to 1 over square root of x and you wrote that instead, that is perfectly fine. So yes, full credit for that. And so I would definitely say to write the full thing. If it's a free response, you guys want to think of it as they're grading for credit for your expressions. So if it was a multiple choice and you wanted to stop there, that's fine. But for free response, make sure you guys complete your thought. So I'm always going to say that, complete your sentence, complete your thoughts. Okay, so infinity is the answer. And then the statement, it diverges because it's infinite. If you look at the question, it says show that it is divergent. Okay, so the second part of it, plugging g of x in, we get this expression where b -4 is at the bottom. Now, if you guys integrated it, you would have gotten something that is the square root on top and then to the first power at the bottom. So if we let it go to infinity, your bottom is bigger. So therefore, you're going to get a limit that's finite.